let us study capillary rise, and let me find out the how much it will rise or how much it will go down. So before we study that rise and fall, we need to know this excess pressure inside a liquid trough. So I have done in my previous video. So this is the internal pressure and this is the outside pressure. Then it will give excess pressure will be Pi minus P naught equal to 2S by R. So this S is nothing but surface tension and R is the radius of the liquid trough. And one theorem is rather than this is when you have a liquid column like this of height h and density rho, the pressure difference at bottom and the above is given by P1 minus P2 to rho gh. So this one, so we will use this one, these two equation in calculating the capillary rise or fall. So let me focus on the capillary rise. So for that capillary rise, let me take some stuff here, a container. Let me fill this with water up to this level. So I'm filling it. So as we already know, there is an angle of contact between the solid surface and the liquid surface. So let me say that this angle of contact is something like acute angle. So this is a concave surface, right? So and let me try to put a capillary tube. So a capillary tube is a small tube, right? It's a small fine tube. So when we put this capillary tube, I think, let me see, there might be increase in the water level, and it also form a concave. So this also will form a concave surfaces, right? So let me say that this is H, and let us try to find out how much height increases or decreases, right? So when you put the tube, there will be like this also, and here also this like this. There's some concave surface. So there is a 3 concave surfaces, one here, this one, and one here, and this one here. 3 concave surfaces. And let me focus on this side first. So above the surface, let it be P naught, and just below the surfaces, liquid surfaces, is Pi, pressure, right? So it also have like something like it's following like something like a, so it's like following a liquid drop model. So I'll write like this as P naught inside. My inside is now P naught. Don't confuse with that above formula. So don't confuse with this above formula. So this is internal pressure. So for me, internal pressure is P naught. Okay, minus Pi equal to twice S by R, and the value of R is very large for this kind of concave surfaces, and here angle of contact is also acute angles. So for this, when r tends to 0, p naught equal to pi. So this is the main thing here. So let us zoom in. So after zooming in, I'll say same horizontal पे यहाँ पे p naught होगा, because p naught equal to pi and this pi is equal to pi and here p naught. And in this capillary tube, let me say the pressure above is p naught again, and here just below the is p. So let me write for this liquid column first. So it will be p naught minus p equal to rho g h. So this is another one. And for this concave surfaces also, p naught minus p r. So I'm not describing the r here. So to understand this type, let me draw a nice figure here. The tube with enlarged view. The tube with the enlarged view. So it is like this. The tube is filled with water like this, and the tube length is a here, and here let me draw the angle of contact here. So this will be the angle of contact theta, and let's say, let me draw a perpendicular here, and say, let us think this curved surface is completed a sphere of radius r. So this will be angle theta, and if I have to draw this, it will be like this. It will be like this. So with a here, r here. So this is theta. So your cos theta is equal to a by r. From here, let me calculate a r. So guess it, a by cos theta. So let us see the whole view here. So let me try to let me equate these two equations. Left sides are equal, so rho gh will be twice s by r, and rho gh will be twice s by a cos theta. So from here you can calculate h. A rho g twice s cos theta. So this is the value, I think. So if the theta is less than 90 degree, ice increases. What about theta greater than 90 degree, it decreases. So when the angle of contact is obtuse, then the liquid will fall down inside the tube, and if the angle of contact is greater than less than 90 degree, it will rise up. So that's very easy, right? So if you know the excess pressure formula and that things, so